All right, on this slide is the double angle formulas. These angles you do not have to memorize. So we have the sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. When we look at a graph of two functions, one being y equals the 2 sine of x, and then the second one, y equals sine of 2x, notice that these two graphs are not the same. So this would not be correct if we had the formulas. We really want you to know that they're not the same. So we're going to go ahead and use an example of the double angle formulas. So let's say we have a trig function. The sine of theta equals 5/13. This is not one of our special angles on our unit circle. So we have to create an angle that's going to fall in quadrant 2. So here's quadrant 1, and this is quadrant 2. So we have an angle that falls in quadrant 2. So there's our theta. So if you remember from earlier in our course in chapter 4, the sine ratio is your y-coordinate over your radius. So in this case, if we give you the sine of 5/13, our y is 5 and our radius is 13. And we want to find that x value. So we have to use the Pythagorean Theorem. X squared plus y squared equals r squared. We need to find the x, the y, and the r in order to evaluate any of the other trig functions. So the x is going to be unknown, the y is 5, and that r is 13. So we're going to solve it for x. So we get 25 and 169. And now we subtract 25 from both sides, giving us 144. Then we want to undo that squared. So we're going to square root both sides, giving us plus or minus 12. Now we do need to be purposeful if that is a positive x or a negative x. In this case, it falls in quadrant 2, so our x has to be a negative, so a negative 12. So let's go ahead and create our reference triangle. So here's our reference triangle. It's a right triangle. We have our x distance, our y distance, and our radius. Now let's identify those lengths. So the x we just found to be negative 12. Our y was given to us up in our ratio of 5. And then our radius was given to us in our ratio. And this is our reference angle. And then there's some point sitting up here, x comma y, that is negative 12 comma 5. All right, so we did those types of problems back in unit 4. What we're asking you to do is not to find the sine, cosine, and tangent, but to find those double angles when we multiply that angle by 2. So let's start off with the sine of 2 theta. We want to use our formula up above. So here is the sine of 2 theta. It's 2 times the sine of theta times the cosine of theta. So I'm just going to go ahead and write that formula down. 2 sine of theta times the cosine of theta. Well, we know the sine of theta is given to us as 5/13, so we can plug that in. The cosine we don't know yet. So this is bringing us back again to unit 4. To find the cosine, the ratio is your x over your r. So our x is negative 12 and our r is 13. So we're going to substitute negative 12/13 into part A. Now we have to simplify it. So we're going to multiply across. So I'm going to change that 2 to 2 over 1. And now we multiply all of those numerators together. So we're going to multiply 2 times 5 times negative 12, giving us negative 120. And then the denominator is 13 times 13 is 169. So the exact value for the sine of 2 theta is that ratio. All right, let's now find the cosine of 2 theta. So we go up to our formulas. Here's the cosine of 2 theta, and we're going to write that formula down. Cosine squared of theta minus sine squared of theta. And now we sub in those ratios. So the cosine of theta right here was negative 12/13. Well, we have to square that. It's saying cosine squared. So we're going to take negative 12/13 and square it. And then sine squared of theta. Sine squared of theta is 5/13. And we're going to square it. All right, so negative 12 times negative 12 is 144. 13 times 13 is 169. So we're simplifying that first fraction. Go to the second fraction. 5 times 5 is 25. 13 times 13 is 169. Now this should be 144, excuse me, 144. So now we go ahead and subtract those fractions. They're alike. So when we subtract them, we take the numerator and subtract over the denominator. So there's the exact value for the cosine of 2 theta. All right, last one. The tangent of 2 theta. So we go up and find the formula. Here's the formula. Well, we need to know who is the tangent. So we'll be doing that in just a moment. So I'm running out of room here, so I'm just gonna erase a little bit here. I'm gonna write that green part off to the right. All right, so we have some room to write. So the formula for the tangent of 2 theta is 2 tangent theta over 1 minus tangent squared of theta. Well, in the pink and the green, I have the sine and the cosine. To do the tangent, it's your y over your x. So the y was 5 and the x was negative 12. So there's the tangent. So now we're going to substitute into the formula. So 2 times negative 5/12 and then 1 minus negative 5/12, and we have to square it. So we have a problem that needs to be doing some more simplifying. So let's go ahead and multiply the numerator. So 2 times negative 5 is negative 10 over 12. And then in the denominator, negative 5 times negative 5 is 25 over 144. We do need to simplify that denominator a little bit more before we can keep, change, flip. So I'm going to change that 1 in the denominator to 144 over 144. So I can subtract those two fractions. So now 144 minus 25 is 119. So the numerator is still negative 10/12. The denominator now is 119/44. So now we have a single fraction dividing another single fraction. So we can keep, change, flip. So we keep the negative 10/12. We change it to multiplication, and then we flip it. All right, so before we multiply across, we want to reduce any common factors. There is a common factor with 12 and 144. We can divide both of them by 12. So this will become a 1 and a 12. Now we're able to multiply across. So negative 10 times 12 is negative 120 over 119. So there's the exact value.